So in this video here, we're going to take a look at how we can use the Yolo 8 model from Ultralytics to do retail analysis. So we're going to run through a bunch of different examples so you can create heat maps of retail stores, can pretty much be used for doing analytics. Heat maps where people moving and so on could be in retail stores, shopping malls, and so on. It can even be used in traffic intersections. So it can be used for a ton of different things. We need to do object detection, but also object tracking. And then by using that information and some weighting depending on the position in the frame, we can basically just create a heat map where we can see where are the most people, or basically the specific objects that we want to do heat maps for. So let's just jump straight into the Ultralytics documentation. If we go inside the new solutions tab, we can see all the different real world projects that you can use out of the box with the Ultralytics framework. So we have videos of pretty much all of them over here: speed estimation, distance calculation, queue management, security alarm systems. But right now let's go down and take a look at the heat maps. We already have one for traffic analysis, but this is also very important in retail stores and retail analysis in general. So it's basically just going to detect people or whatever object that you specify, the different classes. You can use your own custom models directly with the Ultralytics framework as well. So you can just train that. We have videos covering the whole training pipeline and how to set up a whole computer vision system. So when we're doing it for retail analysis, it's really good to see the data distribution. You can see where are people moving in your store and so on. Then you can place different items depending on where are the most people, what regions are people in, but you can also go in and detect different kind of patterns, so efficient pattern detection and also spatial analysis and decision making based on that. So you'll be able to extract information of the most popular locations in your store, shopping malls, or pretty much whatever you want to create heat maps around. And this is very helpful if you have products that you want to basically just sell out there. Put them where there's more people walking. Could also be retail shelves. You can just have a camera monitoring retail shelves. You can detect those specific objects, and then you can see how they're moving over time to see popular products. So this is pretty cool. We can just go down and take a look at the examples. So you can do heat maps, line counting, polygon counting, and also specify the specific classes. Down here we can see all the arguments that we can specify. Very nice descriptions. It's just a single line, and then we can specify the values, but they also have default values that we can just use out of the box. So we can use different types of color maps depending on how we want to display the results. If you want to use and view the image, output it, and so on, and also the different colors that we want to use. So it's going to combine both object detection and also object tracking, because the tracking part is really important to be able to generate the heat maps. So it's going to detect each individual object, track it with an object tracker, assign an ID to it, and then it can basically just track that over time, draw a trajectory, and then accumulate all those values depending on the pixel values. So if you have a whole heat map, every time you have a single pixel and you have an object tracked in there, you can basically just have an incrementer. So you just have another image, which is your heat map. So it's just a single layer, and then you can just increment the pixel value. So this is kind of how it works simply under the hood. So this is pretty cool. Let's now go ahead and take a look at some examples. So I'm going to copy this to my clipboard, open up Cursor, my code editor. There we go. And then we basically have our heat map Python file. I can paste it in directly. Right now, let's go ahead and use the small model, the Yolo 8 small model, but you can use an arbitrary model, even your own custom trained ones. Let me zoom in a bit. There we go. Specify the video path file. We have the Dubai Mall 2 video example here. So it's 30 seconds, basically just walking around in Dubai Mall. There we go. And then we can create heat maps based on this. But this is a moving camera. You can also have a static camera, which would probably be a bit better. So here we have an example with a static camera, and then we should be able to create heat maps for these escalators. So now go back again. We use the Yolo S small. So now we just copy pasted the path into the Dubai Mall 2.mp4. And we pretty much don't have to do anything else. It's going to store the video file as well. So all the results will be stored in this heatmap underscore output.avi. And now we can specify the classes that we want to use for heat maps. So these will be the Coco classes. So right now this is cars and persons. It doesn't really matter with the cars. We don't have any in this example, but you can just delete them or specify depending on what you want. So we just have a 0 here. For person detection, we're pretty much good to go. It's going to open up your video stream. You can use any video stream, RGPS stream, webcam, video file, and so on. So now we open a terminal. Then we just take a frame, flow through the whole process with our heat map generator. So inside our solutions, this is basically the module where we have all the solutions from the new solutions tab inside the documentation. So I'm going to activate my content environment. And then we can just run the Python script and take a look at the results. So heatmap.py, and this is the Dubai to video, which is the 30-second one moving around. And now we're basically just going to have this dynamic camera. We can see that we have this circular pattern, but you can change that depending on what you want. So right now we can just change the shape here. We just have circle for now. Then we need to specify the color map, so you can play around with the color map depending on how you will visualize your data. So this is pretty cool. Again, we're just tracking these persons in front of us, and then we're drawing a heat map based on how they're moving with respect to the camera. So everything will be respect to the camera, all the positions and so on. So you should definitely play around with that. If you have multiple cameras, you can combine all of that and basically just have a mapping from camera to camera with your heat maps. So this is pretty cool. Let's go ahead and take a look at the example for the other one where we have a static camera. It will probably be a bit more suitable for a real world scenario. So this is called superdry.mp4, and we rerun it. This runs around like 100 milliseconds inference time on my MacBook Pro here. So it's just using the CPU. It will run significantly faster if you have a GPU available. It's going to do that, use that automatically if you have it set up in your environment and on your computer where you run the code. So this is basically just the Dubai Mall. We can see the escalators, so you can use this to see how's the pattern, how many people are going up and down for the specific escalators here. You can probably even go in and scale it, go in and do modifications on it depending on how far they are from the camera. So you also need to take that into account. But this is a pretty cool example. We can see that the darker the color is, once it becomes like yellow, dark red, dark yellow, and so on, we have more heat in that area. So we basically just have more detections. We have accumulated more pixels up depending on our tracked objects. You can track whatever object. You can use your own custom objects. You can use the pre-trained models. You just need to specify the classes. So this is pretty much it. This can be used for retail analysis in shopping malls, stores. If you have a retail store, just have multiple cameras here and there, and then you can generate these heat maps, but also for sports analytics. The video file will be stored. You can use that, but all the results can also be extracted to do further analysis on top of. So I hope this is useful. Definitely go ahead and check it out. You just have to copy paste this code snippet, throw in your video file, you're good to go, and you can use it in your own applications and projects. So thanks a lot for watching. I hope to see you guys in one of the upcoming videos. Until then, happy learning.